Good morning, students. Class 12th, Chapter 5, Lecture 6, Homework Solution, and Lecture number 7. So, in Lecture number 6, what was given as your homework is Exercise 5.4, some of the questions, right? So, I'll discuss out of them 2 or 3 questions so that you can match up your answers and can get to know how those questions were to be done. Let us start. Exercise 5.4, question number 7 I will be discussing. In this question, they are asking you to differentiate. In under root, they have given a function e to the power root x, where x is greater than 0. Why x is greater than 0? Why is this condition applied? Because if x is less than 0, it will become an imaginary number. So you will assume y as equal to this function. Now differentiating both the sides with respect to x, you will get d by dx of in square root e to the power root x. Correct. So first of all, when we do of root x, the power is half. So half will come in front and the power will become minus half, because what we do is half minus 1. Actually, I can show it by writing d by dx of, we are doing e to the power root x whole power as half. Clear? So in under root, we will have minus half. So we will write it like this. Clear? Now, right now we have done for power function. Now we will do for e to the power root x. Correct? We know the differentiation of exponential functions remains the same. d by dx of e to the power root x will be e to the power root x into differentiation of root x now. Applying the chain rule, we are doing it. Correct? Now applying the chain rule, see what do we get? 1 by 2 under root e to the power root x, e to the power root x, this I am writing this one in the numerator, into 1 by 2 root x. So you can just combine the terms and write your answer. Just multiply the denominator. Okay. This is the answer for question number 7. I hope you might have done this also. Most of the students were able to do this. Let us go to the next question. So now I'll discuss question number 8. Question number 8, the function given is log of log x. So this is the function which we have to differentiate. Differentiating both the sides with respect to x. We get d by dx of log x. You know differentiation of log x is 1 by x. Right now this is working as complete function inside the log. So 1 by log x. Right now we have done for this. Now we will do for this. So we will write d by dx of log x now. Clear? So 1 by log x, and of this log x the differentiation will be 1 by x. So the answer would be 1 upon x into log of x. This is how you are going to solve question number 8. Let us discuss one more question of homework, which is question number 9. In question number 9, the statement or the function which is given to us is cos x upon log x. We have to differentiate it. Now, differentiating both the sides with respect to x, you know this is in the form u upon v. That means we have to apply here the quotient rule. You can consider this as u, this as v. You know the formula for d by dx of u upon v. It is, in the denominator we write v square, right? V as it is differentiation of u minus u as it is differentiation of v. So let us apply this formula here. In the denominator, what we will have? Log of x whole square. Clear? Then log of x as it is. Clear? Of cos x, the differentiation will be minus of sin x minus cos x as it is. Differentiation of log x will be 1 by x. Clear? Now we can take the LCM in the numerator, because here we have x. So if we take the LCM as x, I can also show you just to see. So if we take LCM as x, what we get? X minus x log x into sin x minus cos x. Clear? And in division, what do we have? Divided by log of x whole square. So what we can do is, we can separate the terms also. We can, write it as minus x log x. We can take minus common, x log x into sin x plus cos x whole divided by x into log of x whole square. Now you can leave it as this also, or you can just separate the numerator part with the denominator, both the terms, and write the answer separately. This is how you are going to do question number 9. Now I will start with a new concept which is known as logarithmic differentiation. Till now, what we have learned, it is really important to understand this differentiation as it is used in most of the cases, right? So see, learned whole power, or let n to the power f of x, or I say n to the power n, where f of x is a function, x is your variable, and n was the power, or n is a constant number, I say. N is a constant number. Correct. So we have actually differentiated all these kind of functions. Now I can give the example. Suppose here you have a sin x to the power 2. We know how to differentiate it. If we have 2 to the power x, we know how to differentiate it to apply the formula of a to the power x. N to the power n, it is a constant, so differentiation would be 0. So these are all the functions that we have already done. Where logarithmic differentiation comes into role is, if you have, now what we are going to learn in this section is, we will learn when we have function to the power function, right, or variable to the power variable, or we have like more than two functions in product, more than two functions in product we have, right? So these are the things or the cases where logarithmic differentiations comes into play, and we have to apply logarithmic differentiation there, right? So how we are going to apply this and solve this? Let us understand it with NCERT questions itself. So I'll be just taking questions from your NCERT exercise to teach you how to do and how to go with logarithmic differentiation. Here, so remember, whenever you have variable to the power function to the power function, function to the power variable, here comes the role of logarithmic differentiation. Let us start with one question. So I'm starting with question 1 only of your exercise. Okay, I'll mention the exercise also. This is your exercise 5.5. Clear? And I am discussing question number 1. In question number 1, they are asking you differentiate the function. The function given is cos of x into cos of 2x into cos of 3x. As we see here, we have more than two functions in product. Right now, there can be different ways of solving it. Some students can consider it as u and it as v. Right, can differentiate it and then again apply the product rule. So you see, you have to apply the product rule 2 times, which is time consuming. So to avoid that, we will use logarithmic differentiation. In this differentiation, we take logarithm on both the sides. So we will write taking log on both sides. Clear? So before doing the questions, some properties of log which you have done in 11th standard also and 12th also, when we did our logarithmic function in the first chapter. So they were made I made you to write them in your notebook. So I'll also discuss them once so that there is no confusion. Now just to take log on both the sides, you will get log of y equal to log of cos x into cos of 2x into cos of 3x. Here, now we will differentiate both the side with respect to x. Before that, just see if any property of log can be applied. You see it is log of P into Q into R, or I say log of A into B into C. You know very well that log of A into B into C equals log of A plus log of B plus log of C. So applying this property here, we will have log of cos x first. Here, log of cos x plus log of cos of 2x plus log of cos of 3x. Here we have log y equal to this thing now. Now we will differentiate both the sides with respect to x. So you will write differentiating both sides with respect to x. With respect to x. So when we do that, we will write d by dx of log y equal to d by dx of log of cos x plus d by dx of log of cos 2x plus d by dx of log of cos 3x. Clear? So let us differentiate. So we'll keep this content on one page and we'll take another sheet to write this. Now you just see what will be d by dx of log y. For log y, we will have 1 upon y. Right? Right now we have done only for log function, as you can see. Now we will do for y. So what we will have? Log y. For log y it is 1 by y, and for y it will be dy by x equals. Let us see the first function. In the first function you see d by dx of log of cos x. So log of cos x will be 1 by cos x, and then of cos x we will do, which will come as minus sin x. So we will write it. D by dx of log of cos x is 1 upon cos x. Okay. And of cos x it will be minus sin x. Here, similarly, log of cos 2x will be 1 upon cos 2x. Okay. And of cos 2x it will be minus sin 2x. And then you will do for 2x. It will be 2. Here it was x only, so it is 1 only. Clear? In the third one, you have cos of 3x, as you can see. So log of cos 3x will be 1 upon cos of 3x. Then of cos 3x it will be minus sin 3x. Clear? And for 3x it will be 3. Clear? Let us combine log sin and cos, and then write what we can write in the more simplified way. So minus sin upon cos will become minus 10x, plus minus will be minus sin 2x upon cos 2x, minus of 10 2x into 2, right? Or I can write, this is a constant number, I can write it here also. In the next one we have again plus minus will be minus. Sin 3x upon cos 3x will be minus of 10 3x, and into 3 we have, so I am writing that constant value here. So this is actually what we are getting after differentiating. Here we have 1 by y dy by dx. Now we just have to find out the value of dy by dx. So what we can do is, we can shift this y or transpose this y or multiply both the equations with y on both the sides. So you will get, if I take minus out, 10x plus 210 2x plus 310 3x. Okay. Into we have y. Correct. And we already know the value of y. See, what was y that we assumed? This is y. Cos of x, cos of 2x, cos of 3x. Let us put this value there. So we will have minus of 10x plus 210 2x plus 310 3x into value for y is cos x, cos of 2x and cos of 3x. So this will be the answer for your question. In some books or like some of the students, what will they do is, they'll not convert it into 10 and then they'll take the LCM, cancel the terms which are possible and then write the answer. That is also the correct way of doing it. This is also one of the way that you can write the answer. Don't get confused if your answer mismatches. Sometimes you don't simplify it to that form and don't get the exact answer which is given in the book. Your method and differentiation should be correct in doing so. Always go for the simplified way as much as possible. So this was one of the question number which is question number 1 of exercise 5.4. I hope this is clear. 5.5. Now I will discuss one more question of the exercise. Let us discuss. So the next is question number 2 itself. Let us do question 2. Okay. In question number 2, they're asking you to differentiate y equals, in under root we have been given x minus 1, x minus 2 divided by x minus 3, x minus 4 and x minus 5. This is what is given to us. Now we will again, because we see that more than 3 functions are in product, right? Also the power is there, also the division is also there. So log will make it easier for us to solve. So I can write it as y equals x minus 1, x minus 2 divided by x minus 3, x minus 4, x minus 5 whole power as 1 by 2. You know very well that log of a to the power b is equal to b log of a. Correct? So we will apply this here. So taking log on both the sides, we will have log of and this complete value. Correct? So I will write x minus 1, x minus 2, x minus 3, x minus 4 and x minus 5. Clear? Now applying this formula, what is b here? Half. So half will come in front. 1 by 2 log of, you have x minus 1, x minus 2 divided by x minus 3, x minus 4 and x minus 5. Clear? So now the power is in front. Now you see carefully, we have log of a upon b. Log of a upon b means log of a minus log of b. This is also the property of log which we have already discussed. Now just to see, we will have log y equals, so we will differentiate once we apply the property of log and the expression is simplified. So what we will write is log of, or I should write it in separate place, it will be much clear for you. So I am writing it, see, we have a as x minus 1 and x minus 2 and we have b as x minus 3, x minus 4, x minus 5. So I'll just write it. We will have log y equals log of a, which is x minus 1 and x minus 2, okay, minus log of b. B is x minus 3, x minus 4, x minus 5. See, you can see here, we had this as a and this as b. Clear? Now, as you know, log of a into b is log of a plus log of b. Correct? Minus. Similarly, here these all three will be added, but as there is a negative sign outside, so the negative sign will come minus log of x minus 3, minus log of x minus 4, and minus log of x minus 5. Clear? So this is done now. Now we can differentiate both the sides with respect to x. So you will write differentiating both sides with respect to x. Clear? So when we differentiate both the sides with respect to x, we will get 1 by y dy by dx. Okay. Here see, what will be differentiation of log of x minus 1? It will be 1 upon x minus 1. And when you do for x minus 1, just to see, of x it will be 1 and of 1 it will be 0. So it will be 1 itself. Plus log of x minus 2 will be 1 upon x minus 2. And differentiation of x minus 2 will be 1 minus 0, which is 1 again. Minus, similarly we can write for x minus 3, we can write for x minus 4, we can write for x minus 5. Here, so this is what we are getting after differentiation. Now we just have to find out dy by dx. So we need to multiply both the sides of the equation with y so that y is not here then. So multiplying both the sides with respect to y, we get 1 upon x minus 1 plus 1 upon x minus 2. You can take the LCM also, okay? Minus 1 upon x minus 3 minus 1 upon x minus 4 minus 1 upon x minus 5. Now, what do we have in y? Instead of y, we had the complete function, as I can show you from the starting. Y was equal to this. This is the value that you have to place in the place of y. Here you will be placing the function which was given to you. Clear? So I can also write here what was the function? In under root we had x minus 1, x minus 2, and in the denominator we had x minus 3, x minus 4, and x minus 5. Here, so this is how you are going to solve, or how differentiation makes it easier and less time consuming for you people to solve the questions of differentiation. Now, so these were the questions where more than two functions are given in product and so on. Now I will discuss a question where function to the power function is given to us. Clear? So let us go to the next question, which is question number 4. So I'll just write the statement of question 4. In question number 4 of exercise 5.5, they're asking you to differentiate this and find out the value for dy by dx. This is given to us. Clear? Whenever things of this kind are given, you will consider one function as u, another function as v. Correct? So what we will have? Y is equal to u minus v. So what will be dy by dx? You just see, you will have du by dx minus d by dx of v, dv by dx. So actually we have to just get to know this, and we will be finding dy by dx. Now our purpose is to calculate the value of du by dx and dv by dx. Let us first get du by dx. What is u equal to? X to the power x. You see, it is variable to the power variable. Okay, so we can't apply this identity as we were doing the differentiation of x to the power n as how? N into x to the power n minus 1. Here n was a constant number. But here this can't be a constant number, right? So we can't use the formula. We will take log on both the sides. So we will write log of u equal to log of x to the power x. Fine. Now what will happen is, you know, log of a to the power b is there, it comes in front. So we will have it as x into log of x. It is equal to log of u. Now we will differentiate both the sides with respect to x. So now you will write differentiating both sides with respect to x. When we differentiate both the sides with respect to x, you will have d by dx of log of u equals d by dx of x log x. Now you see there are two functions, so we can apply the product rule here. Here it will be 1 by u, and when you do for u, you will get du by dx equals, let us apply product rule here. First function as it is, d by dx of log x plus log x as it is and d by dx of x. Clear? So just to see here, x as it is, log x differentiation will be 1 by x and of x it is 1 plus log x as it is and d by dx of x is 1. So we actually are going to cancel x and x. We get 1 plus log of x. Clear? Here you have 1 by u, du by dx. Now to solve the question, I just need du by dx. So I'll shift this u to another side or transpose this to another side. You get du by dx equals 1 plus log x into u. Correct? And what is the value for u? We have x to the power x. So I'll just write it that what is the answer that we are getting for du by dx. We are getting it as 1 plus log x, and instead of u I am putting x to the power x, as you can see here. Clear? Now we will solve v. Let us see what kind of function is v. I'll write on the new page itself. So I'll just mention it as equation 1. Okay. Now v is given as 2 to the power sine x. You know a to the power anything, or I say to the power a variable or a function when you have. What is the differentiation of this? It is a to the power x into log of a. Correct? This is how we solve it. Or also we can do it using log. So let us take log on both the sides. Log v equal to log of 2 to the power sine x. Now log of a to the power b, you know b will come in front, which is sine x, into log of 2. Here log of v is there. Now differentiating both the sides with respect to x, 1 by v dv by dx equals, you know log 2 is a constant, so log 2 as it is. Differentiation of sine x will be cos of x. Clear? Now we just want the answer of dv by dx. So both the sides I'll multiply with v. So dv by dx will come out to be log 2 into cos of x. What will be the value for v here? V is 2 to the power sine x. So we have log 2 into cos x into 2 to the power sine x. Now let us consider this as equation number 2. Just to see, to find dy by dx, we have to place the value of du by dx and dv by dx. So we now have from equation 1 and 2 du by dx as well as dv by dx. Just put these values in that and you will be finding the answer for dy by dx. So this is how we solve whenever a function to the power function or a variable to the power variable is given to us. Clear? Now I will discuss the last question of the lecture, which is question number 6. So actually what I am doing is I have discussed all the type of questions where you get function, more than 2 functions in product. You have function to the power function or the variable to the power variable. Right. Now let us discuss one more question, which is question number 6. So in question number 6 of exercise 5.5, they have given the function as x plus 1 by x whole power as x and plus x to the power 1 plus 1 by x. These are the two functions where variable to the power variable, or you say function to the power function, is given. So we are going to solve it using log. Now students, try to take log in this equation only. But do we have any formula? You will have log a plus log of b. Right? It is not equal to anything, right? So what we do is we take them separately for our ease and then solve it. Like you take it as u and you take it as v. Y is equal to u plus v. So dy by dx will be just equal to du by dx plus dv by dx. Clear? This is how you are going to solve. So what is u here for you? U is x plus 1 by x whole power. Let us name this as equation 1 to the power x. And what is v for you? X to the power 1 plus 1 by x. Clear? So I will just solve for u. V you can solve yourself at home and can complete the question. So just for your ease, I am telling you how to write for u, right? Just to see. Let us solve u on a separate page. For u, we have been given x plus 1 by x whole power as x. So when we take log on the both sides, we get log u equal to log of x plus 1 by x whole power as x. So this will come in front as log of a to the power b is a into log b into log of a. Log of. Now differentiating both the sides, you see there are two functions, one is x and one is log of x plus 1 by x. So while differentiating it, we'll use product rule. Here we can directly write 1 by u du by dx equals x as it is. log of x plus 1 by x is 1 upon x plus 1 by x. It will go in the denominator. Now you will differentiate for x plus 1 by x, because right now we just have done for log. So for x the differentiation is 1, and for 1 by x the differentiation is minus 1 by x square, because you can write it as x to the power minus 1. Clear? So what we have done, first function as it is, differentiation of second we have done. Now second function as it is, okay, and we will differentiate first. First function is x, whose differentiation will be 1 itself. So I will write the next steps here only so that you can relate. So 1 by u by dx equals, just to see, I will combine all these terms. So what do I have is x, okay, upon, let us take the LCM here. So you will get the LCM as x, upon you have x square plus 1. Okay, here you will have, after taking the LCM, x square minus 1 upon x square. Clear? So this x will go up. It will be x square upon x square plus 1 into x square minus 1 upon x square we have. So the answer that we get for this part only, right now I am into this only. So x square minus 1 upon x square plus 1 you get. Plus, with plus we had log of x plus 1 by x. So here also you will write log of x plus 1 by x. This is the second term. Clear? So this is what we are getting, 1 by u du by dx. Clear? Now what will be du by dx? We will transpose this u onto another side. So du by dx will be equal to x square minus 1 upon x square plus 1 plus log of x plus 1 by x into u. You can see, just this is the equation that we are getting, right? Okay, so instead of u, we have to put the value of u, or we have to replace u by its value. So we will just write it as log of x plus 1 by x. What is the value of u? What was u initially? Just to see, x plus 1 by x to the power x. So I'll just write that x plus 1 by x whole power is x. So let this be your equation number 2 then. Okay, so you have, as I have calculated du by dx, you can now calculate d by dx. Here, can add them and write the answer. Here, so it's up to you. Sometimes, the answer would be given as by solving this, like this can be further solved as x square plus 1 upon x. Clear? So log of a minus b can be applied here. You can leave the answer like this also. There is nothing wrong in it, but it is good if you simplify it, right? So don't get confused when your answer doesn't match the exact answer to other students. Clear? So it is up to everyone. Otherwise, it is always recommended to write in the simplest form only. Clear? So this is all for logarithmic differentiation that we have done today. So homework. What you are going to do from exercise 5.5 is, I'll tell you the question numbers. From exercise 5.4, questions that you are going to do is question 3, 5, 7, 8. You will complete this 6th question also, 9th, 10th and 11th. Clear? So you solve them. The next day you are going to get the solution of these and you can match your answers from there. So that's all for today, friends. Thank you.